This video is for section 4-6, GCF and LCM of polynomials. The common factor of two or more polynomials is a polynomial that is a factor of each of them. And a common multiple of the polynomials is a polynomial that is a multiple of each of them. You have found GCF and LCM just a couple sections ago. And we can use the same techniques to find GCF and LCM of polynomials, if the polynomials are in factored form. So in the past few days, we've practiced factoring polynomials. Here's our first application of that skill. Factoring polynomials will help us find GCFs and LCMs. For example, find the GCF of this trinomial and this trinomial. Let's factor each of them. This first trinomial has a greatest common factor of 9x. And that leaves x squared minus x minus 2. That trinomial can then be factored using the double parenthesis pattern, x minus 2 and x plus 1. Now let's factor this trinomial. Its GCF is 6x to the third power. And that leaves x squared minus 4x plus 4. That trinomial is a perfect square trinomial, which can be factored with one set of parentheses with squaring on the outside. And in here is x minus 2. You can see already that being able to factor quickly and accurately will help you to answer these questions. Now that we've written both polynomials in factored form, we can create the greatest common factor. Start with the numerical factors, the 9 and the 6. What is the GCF of 9 and 6? It's a 3. 3 is the largest number that divides 9 and 6. Now the variables. Is there an x in both polynomials? There is. What's the most amount of x's in both of them? It's a single x. The second polynomial has more than one x, but the greatest common factor is limited to a single x because that's all that's in this polynomial. Now let's look at our binomial factors. This polynomial has a binomial factor of x minus 2. Does the other one? Yes, it does. So there's an x minus 2 factor in the GCF. This polynomial has a binomial factor of x plus 1. Does the other one? No, it doesn't. So x plus 1 is not common to both. Our greatest common factor is 3x times x minus 2, which could be multiplied together to get 3x squared minus 6x. Here is the greatest polynomial that is a factor of both of the original polynomials. Next example, let's find the LCM of those same two polynomials. So the first step was to write factored form. You can copy that down from above. Now let's find the LCM. Start with the numerical factors, the 9 and the 6. What is the least common multiple of 9 and 6? It's 18. 18 is a multiple of 9, and 18 is a multiple of 6. Now let's look at the x's. The LCM is x to the third power. Now let's look at the x minus 2's. The LCM is x minus 2 to the second power. And then the x plus 1. Here is the least common multiple in factored form. Let's try another example of finding GCF, this time with 3 polynomials. The first thing to do is write them in factored form. This is a difference of squares, and it factors as z plus 6 times z minus 6. 6 plus z doesn't factor, but it might be worth using the commutative property to write it as z plus 6, because that helps us recognize that that's common to the z plus 6 in the first polynomial. Our last polynomial is 6 minus z. 6 minus z is equivalent to the opposite of z minus 6. The reason that I rewrote it was to recognize that z minus 6 is common with a factor in the first polynomial. Now let's get the GCF. Is z plus 6 a factor in all three polynomials? No, it's not. Is z minus 6 a factor in all three polynomials? No, it's not. Therefore, the GCF is 1. Let's use those same three polynomials and find the LCM. Remember to use factored form. The difference of squares factored into z plus 6 times z minus 6. The 6 plus z was equivalent to z plus 6. And the 6 minus z was equivalent to the negative of z minus 6. Now let's get our LCM. From the first polynomial, we see that it must include a factor of z plus 6 and a factor of z minus 6. When you look at the other two polynomials, are there any factors we haven't yet included in our common multiple? Only thing we haven't yet included is the negative sign. So let's put that negative at the beginning. Here is our least common multiple in factored form. Let's summarize the lesson. A couple lessons ago, we looked at GCF and LCM, and we expanded those skills to polynomials. To find the GCF or LCM, it's important you first factor your polynomials. Then you can see what factors are in common.